This module is one of 15 foundational concept topics for maintenance planning. There are modules for project management that any organizational change effort can use to realize the change goals. And there are modules for the people aspects of making those changes stick. This module covers proactive workflow, which is the reorganization of reactive maintenance work, waiting for breakdowns, to proactive work. The benefit of proactive work is that we can plan for work and level resources while moving maintenance activities into downtime. Many organizations run a reactive workflow model. It's easy to wait until machines break down before maintaining them. No prioritizing of work is required, and some people look like heroes if they can get machines up and running again. But unpredictability and parts shortages are often an issue. Reactive maintenance often focuses on simple fault finding or PMs in addition to breakdowns. Many folks drive their cars like this too, waiting for noisy bearings, overheating, or just knowing that it's time to change the oil. That may be okay for home, but it's a high-risk way to run a business. Under reactive workflow, fewer PMs are completed than are planned. Many of them require urgent attention and combine with breakdowns to encourage parts chasing. Daily work is poorly coordinated and wrench time is low. Running inspections are rare. Reactive maintenance shops struggle to improve. Everyone has ideas about what needs to be done differently, and some of those make their way into SOPs. But the SOPs are not universally followed, and ideas are not tested to see if they actually increased asset health. Best practice sites start with an in-depth understanding of their assets. If a site does not know what defects are present in their assets, what will they plan and schedule? Criticality analysis tells us which asset functions to prioritize. FMEA tells us how. Then we create the EMP. A good maintenance plan tilts the maintenance activities heavily towards preventive or predictive, up to 80% instead of 20%. Most planning is then created by scheduled inspections, some of which are conducted during downtime, but many of which are done during production. Even when the proactive workplace is in effect, a fifth of all work can still be requested work as a result of failures and breakdowns. The ability to respond quickly to these is still paramount, and scheduling has to be flexible enough to insert requested work at the right prioritization. Just working diligently at PMs and PDMs is not enough, though. 2 continuous improvement loops are required, both of which need time and resources. The first is improving job plans based on lessons learned from planning. The second is a robust root cause fracas system. Even when we have less PM and a more robust PDM process driving 50% of total maintenance labor hours, we must actively look out for changes in products, technologies, and procedures, and change our maintenance practices accordingly. Good MOC is critical. Driving the proactive maintenance system generally requires improvement work across the entire department. BOMs can be polished and criticality revisited and reworked. That means new FMEAs and revised plans. Processes for PM creation, RCFA, and job planning can usually be improved. Even when we have less PM and a more robust PDM process driving 50% of total maintenance labor hours, we must actively look out for changes in products, technologies, and procedures, and change our maintenance practices accordingly. Good MOC is critical. Driving the proactive maintenance system generally requires improvement work across the entire department. BOMs can be polished and criticality revisited and reworked. That means new FMEAs and revised plans. Processes for PM creation, RCFA, and job planning can usually be improved.